Hi guys, I hope you all are doing well. So today we have a certain topic which nobody likes much, okay? So it's from the real numbers, the fundamental theorem of arithmetic. Now this is very simple, yet one finds it a bit, okay, confusing. So here I have this theorem to enable you to understand with clarity, right? So it states that every composite number can be expressed as, for those who do not understand well composite numbers and prime numbers, for them I have, okay, a little handout here for me so that I am able to make you understand, okay? So prime numbers begins with the number 2. 1 is excluded, okay? So 1 is excluded. Why so? Because prime numbers have to have at least 2 factors. 1 and the number itself. Alright guys. As against this, we have composite numbers. Okay, say we have 15 over here. So there should be, okay, at least 3 factors. There can be more factors also, as I have explained. Okay, here 56 has got 2 factors here, 2 into 28. When you further, remember factors, not prime factors. In the fundamental theorem of arithmetic, we will be doing prime factors, alright? But you need to know or differentiate between prime numbers and composite numbers. This number should be able to divide with not only itself, say 15, okay, can be divided by 15 itself, and 15 can be divided by 1, okay, 2. Got it? Now apart from these two, okay, there should be at least 1, say even 3 can divide or 5 can divide over here. So say this divides and we get an answer 5. Am I right? If 5 were to divide 15, we'll get the answer 3. So composite numbers do not necessarily have those 2 factors, the number itself and 1 alone. More than 2. Alright. So which is why these 2 numbers are different. Now here in the fundamental theorem of arithmetic, okay, we are dealing with those integral numbers which are positive in nature. 1 is boycotted, more than 1, and this goes till infinity, right? So all the positive numbers, leaving out the prime numbers, are called the composite numbers. I hope it is clear now. Now I'm shifting this for a better understanding of this. It states that every composite number can be expressed as a product of primes. Okay, product of primes. Remember here we have 28. This is not a prime number. This should be, okay, broken as another 2, and 7. Now if we say 56 in terms of 2 into 2 into 2 into 7, all of them are prime numbers, prime factors thus, okay? So here we have, they have to be a product of primes, correct? And they got to be unique also. Because say I have an example, okay, of 56 which we did there to understand composite and prime numbers. Here we have 2 into 2 into 2 into 7 can be expressed in so many different orders, which is what they are telling. It's unique because when you factorize a composite number, you'll always get the same prime numbers. We are getting the same prime numbers. Order may be different. We have 2 here, we have 2 here, 2 here, 2 here, 2 here, 2 here, 7, 7. Got it? Just the order may be shuffled, okay? So order could be different, but ultimately we have 2 to the power 3 means 2 of 2's, 3 of 2's and 1 of 7. Once we try and visualize or figure out if this had been 2 to the power 2 multiplied by 7, we would have got 28, not 56. So this justifies this statement because it's unique, because when you factorize a composite number, you'll always get the same set of prime numbers. Never less nor more. Although some order may be different. Clear or not? So these are the two highlights of this theorem, fundamental as in the basic of things, that every composite number comes in a package of prime numbers multiplied with themselves to give the product that particular composite number. Why we are able to shuffle them? Because we know that multiplication is commutative. It can commute, it can go from one place to another without altering the product value. Say 2 into 3 can also be said 3 into 2. Am I right? So now you can understand this with clarity, that what are we talking about. So once again, if I would like to explain you that it's a product of primes, you have understood, I'm sure guys. It's unique also, you have understood, because when we express, say if we were to express 3, 4, 6, 8 in terms of prime factors, 2 to the power 2 into 3 into 17 to the power 2. Which means whatever is the order, say if I would write over here 17 into 17 into 3 into 2 into 2, I would be not wrong. Because ultimately when those prime numbers were to be multiplied with each other, they would give me this product 3, 4, 6, 8. Clear? So till here I have made you understand that you will always get the same prime numbers. In some kind of an order, some order, whatever order that you choose. Which means that they can be spread into any order of its prime factors. So for example, we'll prove prime factorization is unique through these examples which I have already jumped and explained to you with reference to whatever text or whatever things were written here. So when we break down the following composite numbers, say 56 and 3, 4, 6, 8, we get the following prime factors for which order doesn't matter as multiplication is commutative. So this is the first example and this one is the second example. You can spread out in so many variations, but this will always be the same, guys. This will always be the same. Their magnitude will still be the same, their powers, exponents, everything will be same. Unless they are same, we wouldn't call them as unique. So how can that be possible? It will alter the value, it will alter the composite numbers if we deduct or take out one or two of those factors, prime factors. So I hope this is clear. Now we'll get down to doing some of the problems that are given in the first exercise for you all, pertaining to this particular theorem. Alright guys, so if there is still any kind of a query that you have in your mind or haven't understood, do write to me in comment. I really appreciate and look forward to it. But somehow, why do you all shirk from asking any questions? I wonder. So thank you so much for giving me your valuable time. I hope you have understood, and please do subscribe my channel, because if I were to go ahead in future, I need your support. Otherwise I would have to drop out as other YouTubers. Guys, so thank you so much. I hope you understand. Thank you. Bye-bye. Have a great day.